Hey, HannahMouse1 here. In this video, I'll be giving you a tutorial for a basic movement engine. You can use this for pretty much any game where the player needs to move around and collide with objects in the environment, and by the end of the video, I'll cover how to transform this movement system into a platformer and how to use it to make a game with a scrolling background. If you're anything like me, the first game you made in school was probably something like this, a simple maze game where you move around and touching the wall sends you back to the start. Maybe you added enemies, collectibles, or other little twists, but at its core, this was the bare bones version. This is how it was for me anyway. The way this, let's be generous and call it a game, works is by using the when right arrow key pressed event block to change the player's X position. If the script detects that you've hit a wall, it will send you back to the beginning. You then copy this code for each of the 3 other arrow keys so you can move in the 4 cardinal directions. It works, but it has problems. First, it's messy. If you ever want to add new interactions with other sprites, you have to repeat this code 4 times, once for each key. Second, if you press 2 keys at once, like up and right, the game chooses one to prioritize, so you can't move diagonally. On the same note, I personally think that pressing left and right together should cancel each other out and stop you from moving, but here it just picks one and moves in that direction. Third, I like giving players the choice between using the arrow keys or WAS and D for movement to suit different playstyles, but this setup doesn't allow that flexibility. And finally, the movement itself just feels jagged, jerky, and stilted. So I'm going to show you how to make a movement system that fixes all of these issues, works across a wide range of projects, and instantly makes your games feel far more professional. After quickly tidying up the art a little bit, we can delete all of the when key pressed scripts. The only one we'll keep is the when green flag clicked script that sends the player back to their starting position. We're then going to attach a forever loop to this. Now, if you're new to Scratch, you might not realize just how powerful custom blocks can be, but once you start using them, they can completely change the way you build projects. The magic lies in a small tick box labeled run without screen refresh. Here's what that means. Normally in Scratch, if you have a repeat loop, each cycle runs on a separate frame. So a repeat 5 times block will run its contents once per frame over 5 frames. But if you put that same code inside of a custom block and enable run without screen refresh, all 5 cycles will happen instantly in a single frame. This is incredibly useful for all sorts of things, and yes, we'll definitely be taking advantage of it for this movement system. So let's make a custom block with that tick box selected. Name the block movement x input semicolon, and then add a number or text input called x input. Add a label y input semicolon, number or text input y input. Finally, label speed semicolon, number or text input speed. Create this and add it into the forever loop. To fill in the values for this block, there's one important concept you need to understand. Boolean variables, values that are either true or false, can also be represented numerically. In this case, 1 represents true and 0 represents false. For example, take the key right arrow pressed value. It's either true, key down, or false, key up. Numerically, this means it's 1 when pressed and 0 when released. We can use this to calculate which direction the player should move. In Scratch, the X position increases as you move from left to right. So if we take the minus operator and put key right arrow pressed in the first input and key left arrow pressed in the second, we get 1 if the right key is pressed, -1 if the left key is pressed, and 0 if both or neither are pressed. And we can feed that directly into the X input of our custom block. For the Y input, it's the same idea, except we use key up arrow pressed minus key down arrow pressed. And for speed, we'll just set it to 3 for now. We can tweak that later. Next, we're going to make 2 variables, X velocity and Y velocity. When the green flag is clicked, set both of them to 0. Under our movement defined script, set X velocity to X input multiplied by speed, and then change the X position by X velocity. To handle wall collisions, add an if block with touching level as the condition. For this to work, your level should be its own sprite, not part of the background, unless all your walls share a unique solid color that is not used anywhere else. In that case, you could use the touching color block instead, but I don't recommend it. It's far more limiting. Inside that block, add a repeat until loop with not touching level as the condition. Inside the loop, place a change X by block. Here's where the maths comes in, along with the idea of absolute value or modulus. The absolute value of a number is simply how far it is from 0 ignoring its sign. So the absolute value of 5 5 is 5 and the absolute value of -5 is also 5. We'll calculate x velocity divided by the absolute value of x velocity. If x is positive, the result will be 1, as any number divided by itself is 1. If it's negative, the result will be -1. Multiply this by -1 and put that value into the change x by block. After the repeat until loop, set x velocity back to 0. This means that if the player hits a wall while moving horizontally, the game will move them back 1 pixel at a time until they're no longer touching it. And because we enabled run without screen refresh earlier, this happens instantly. Finally, duplicate everything in the define script, but replace every instance of x velocity with y velocity, replace x input with y input, and change any change x position blocks to change y positions. Now, we've got a basic movement engine that's much cleaner than the old system, but there are still a few lingering issues, like diagonal movement being faster than straight movement, no support for WASD controls, and the movement still feeling a little bit clunky. The instant stop when you release a key feels jarring with no sense of momentum. The good news is, because this system is so versatile, we can easily tweak it to add these features and make the movement feel so much smoother. The first thing we'll tackle is adding WASD controls, as that's the easiest change. All we need to do is add an OR operator. In the first input, drop in the right arrow press block from the X input subtraction. In the second input, use key D pressed. Drag that back into the subtraction. Repeat this for the other 3 arrow key checks. Pair left arrow with A, up arrow with W, and down arrow with S. Of course, you can use any control scheme you want. The other day I played a game that used ESDF for movement, which was, let's just say, challenging, but generally sticking to a universal control layout is best for accessibility and player comfort. You might notice that when moving diagonally, the player appears to move slightly faster than when moving straight. This is because if you change the X position by 3 and the Y position by 3, you're essentially moving along the hypotenuse, or the slopey side, of a right-angled triangle. Using the Pythagorean theorem, the length of that diagonal works out to roughly 4.2, which means that you're moving about 1.4 times further than if you were traveling in a straight line. We can fix this by doing something called normalizing the vector, essentially adjusting the movement so that diagonal speed matches straight line speed. To fix the diagonal speed issue, we'll create another variable. Let's call it distance, and add a set distance block at the start of our movement defined script. Drag in a square root of block and set its input to an addition block. In the first slot, put X input by X input, and in the second, Y input by Y input. Some of you may recognize this as the Pythagorean theorem in action. Next, take the multiplication we use when setting the X velocity and place it into the left-hand side of a division block. In the right side, put the distance variable. Then drag this division back into the set X velocity 2 block. Repeat the same process for Y velocity, and that's it. Diagonal movement now matches the straight line speed. Now, let's add momentum. First, right-click the movement define block and choose edit, because we'll need a new input. Add a label called friction semicolon, then add a text or number input with the same name, friction. For now, set this to about 0.9. It must be greater than 0 and less than 1, but we'll fine tune it later. Between the set distance block and the set X velocity 2 block, insert a change X velocity by block. Set it to X input divided by distance. Then change the set X velocity 2 block so it reads set X velocity to X velocity times friction. This gives us a smooth acceleration when the key is pressed and a gradual slowing down when it's released. The closer the friction is to 1, the slipperier the movement will feel, perfect for ice levels or drifting vehicles. Lower values create more drag, ideal for heavy characters like elephants or slow movement through a material such as sand. Next, we'll cap the maximum speed. After setting X velocity, add if X velocity is greater than speed, set X velocity to speed. And if X velocity is less than speed by -1, set X velocity to speed by -1. This keeps the movement from getting out of control if your game has long straight paths where the player could build up too much speed. Finally, I'll bump speed up from 3 to 10 so it doesn't feel too sluggish. Repeat this exact process for the Y velocity, swapping every X for Y when necessary. And there we have it, a fully functioning movement engine that feels smooth, responsive, and can be adapted to most games with just a bit of tweaking. In the rest of the video, I'll show you 2 quick transformations: how to turn this base engine into a platforming engine, and how to adapt it for a game where the player stays fixed at the center of the screen while the background moves, creating a moving camera effect. If that's the part you're most interested in, feel free to use the video chapters to jump straight there. Transforming this into a basic platformer is surprisingly simple. First, remove the set Y velocity 2 block along with the following 2 if statements. Then right-click the movement define script and select edit. We'll add 2 new inputs, gravity and jump height, each with a clear text label. For now, set gravity to -2 and jump height to 15. You can tweak these values later, but generally, lower values will make your character feel heavier and higher numbers will make your characters feel light. Next, find the change Y velocity by block and replace its input with gravity. This makes the character fall. Now go to the if touching level function and move the set Y velocity to 0 into the else section of an if else function. For the if condition, use an AND operator. On one side we need Y velocity divided by absolute value of Y velocity is equal to -1. This checks if the character is falling. On the other side we need Y input is equal to 1. This checks if the character is pressing jump. Inside this section, set Y velocity to jump height. This lets the player jump when they hit a platform. From there, experiment with gravity and jump height until it feels right for your game. And just like that, we've turned our movement engine into a platforming engine. Next, I'll switch back to the basic movement setup and show you how to make the background move instead of the player. First, set the player's starting position to 0, 0, the exact center of the screen. Now create two variables, camera X and camera Y. When the green flag is clicked, set both to 0. At the end of the movement define script, change camera X by the player's X position and change the camera Y by the player's Y position. Then immediately reset the player's position back to 0, 0. Now, when you switch to the level sprite, add a when green flag clicked block and then attach a forever loop. Inside, set the sprite's position to camera X by -1, camera Y by -1. The background now scrolls instead of the player, but there's a small problem. You'll quickly run out of background to scroll through. There's a quick way to fix this, which I'll walk you through now. It's not a perfect fix, but it will work in most situations. Basically, you draw your entire level as a single costume, which will naturally look much smaller than you want. We'll use the set size effect block to blow it up to scale. Scratch does have a limit on how much you can enlarge a sprite, especially with larger costumes, to prevent performance issues. But there's an easy workaround. Create a second costume with a small circle on it. I'll call this costume Sizer. At the start of the when green flag is clicked script, switch to the Sizer costume. Set the size effect to something like 300. Adjust based on how much bigger your level needs to be, then switch back to your main level costume. Now when you play, you'll have a whole level to explore. However, if you want more detailed levels with high quality art, this method won't work very well because the details in the smaller version will blur when scaled up. There is a way to solve this, but it's quite complicated and this video has already dragged on for way too long. If you want me to show you how to do that, let me know and I'll make a tutorial on it. Or as I do like to leave you with a bit of a challenge, you could try and figure out a solution for yourselves. Or if you want something a bit simpler to work on, I would suggest trying to merge the two extensions I proposed and create a platformer with a scrolling background. But now you know the basics of creating a simple and versatile movement engine. Let me know if you'd like to see more tutorials like this, and if so, what you'd like to see. Like and subscribe if you enjoyed, and join the Discord link down below, and I'll see you next week with another video. Bye!